Have you ever imagined embarking on an adventure that transcends the boundaries of what is possible? Exploring the vast and mysterious corners of the universe, just like the heroes of Star Trek? On this epic journey, our protagonists rely on the iOS ship, capable of transcending the light barrier, allowing them to live long and prosperous lives as they explore the galaxy. But what if I told you that, without this advanced technology, they might never see anything but the space void, condemned to boredom or even old age before reaching any meaningful destination? Well, while we're enjoying the adventures of Spock and company, crossing the vastness of the cosmos seems like a trivial feat. However, the harsh reality reminds us that, with today's technologies, a journey to the star closest to the sun would take thousands of years. Even hypothetical innovations, such as nuclear rockets, would take decades. Yes, we are limited not only by the technology we possess, but by the very laws of physics that govern the universe. After all, nothing can move faster than light. Or can it? What if I told you that there is a theory, born from the depths of science fiction, that challenges this reality? An audacious idea that suggests the possibility of folding space itself, creating shortcuts that would allow us to travel faster than light. That's right, the space warp theory, inspired by the expansion of the universe and the inescapable gravity of black holes, proposes a way of traveling through the cosmos in a way that even the Enterprise would be proud of. Imagine, for a moment, the scene. A ship, suspended in a vacuum while around it, space bends, creating a bubble of space-time that glides faster than light. But how do you turn this fantasy into reality? The key lies in Einstein's field equation, which shows us the relationship between the curvature of space and the distribution of matter and energy. From this perspective, we would need a hitherto unknown form of matter with almost magical properties to make this fantastic journey possible. Imagine space as a large, flexible fabric. According to the rules of the universe, nothing that has mass, like people, rocks, spaceships, can move faster than light. But these rules say nothing about space itself moving. The space warp is an idea that first came from science fiction books and movies, such as Star Trek. Over time, some scientists began to think, what if we could do this for real? So space warp went from an idea of fiction to an area of scientific speculation. Let's get to the main point. Space can stretch or compress. We already know, for example, that the universe is expanding, which means that the farthest corners are moving away from us faster than light. This doesn't break any laws of physics, because it's not a thing with mass moving that fast, but space itself expanding. The idea behind space folding is basically to create a bubble around a spacecraft, where the space in front of it is compressed and the space behind it is expanded. This would make the bubble, and everything inside it, including the ship, move through space faster than light, without the ship technically moving that fast. It's as if you were on a treadmill. You can walk on it, movement of the ship, but it's the treadmill that takes you forward quickly, space moving. So, although the ship doesn't move faster than light inside this bubble, the effect of compressing space in front and expanding it behind would make the bubble as a whole, with the ship inside, travel faster than light, taking advantage of this peculiarity that space itself can move like this. This would allow incredibly fast travel across the universe, overcoming the current limitations of space technology. With this example, we'll make it easier to understand. Imagine you have a sheet stretched out, representing the space around us. In the middle of this sheet, we place a sphere, which represents a spaceship. Now, instead of moving the sphere through the sheet, you move the sheet itself. You pull part of the sheet down, creating a sort of valley in front of the sphere, and lift another part of the sheet up, forming a hill behind it. This causes the space, the sheet, around the sphere to curve. If you shift this curvature by moving the valley and the hill together through the sheet, the sphere will follow this movement without it having to move in relation to the immediate space around it. The concept of space folding works in a similar way. Instead of traveling through space, which would be slow even at the speed of light, the idea is to fold space itself, creating a bubble of space-time around the ship. Inside this bubble, the space in front of the ship is compressed, and the space behind is expanded. This allows the ship to surf on this wave of curved space, moving from one point to another much more quickly than it would through normal space. Essentially, the ship isn't moving faster than light inside its space-time bubble. It's the space around it that's moving. This circumvents the rule that nothing can move faster than light, because technically, the ship isn't moving fast. It's space that is being manipulated to move it. Audacious physicists like Alcubierre and Eric Lentz have proposed models that, although challenging, give us a glimmer of hope. Lentz suggests an innovative approach, manipulating space in all directions, potentially eliminating the need for this enigmatic exotic matter. But before we can get carried away with the excitement, we face a colossal obstacle. The energy required for such a feat is so astronomical that it defies our ability to comprehend. We're talking about an amount of energy that the sun would take 1 billion years to produce. And there's more. Faster-than-light travel could lead us to unimaginable paradoxes, where cause and effect become distorted, defying the fundamental laws of our universe. Let's think of an example to understand one of the problems with this type of travel. Suppose you're looking at me while I'm in a spaceship. First, I stand still and throw a ball upwards. Before the ball starts to fall, I activate the ship's speed and approach you at a speed faster than light. Because I'm moving faster than light, you, who are watching, can't see when I threw the ball up. The light that carries this information hasn't reached you yet. But suddenly, you see the ball falling from my hand, as if it had appeared out of nowhere, because the light that shows the ball falling reaches you before the light that shows me throwing the ball up. This creates a paradox, which is a situation where things don't seem to make sense. You see the effect, the ball falling, without seeing the cause, me throwing the ball up. I, in the ship, see the two actions in the correct order, me throwing the ball and it falling. This kind of paradox suggests that traveling faster than light could break the relationship of cause and effect, a very important rule of our universe. If cause and effect are essential to how everything works, then faster-than-light travel might be impossible, because it would mess up that order. So the question remains, is it possible to master space warp, either to surpass it or just to get closer to the speed of light? Perhaps, and who knows? We're closer than we think to unlocking the secrets of the cosmos, using more modest versions of this technology to accelerate our space travel beyond anything we've ever known. Thank you very much for being with me so far. Long and prosperous life to us all, as we continue to explore the vast and wonderful universe that awaits us.